This way.
is in the forest.
Wow.
So grab your loved ones
Don't even.
and explore a world of possibilities.
It's beautiful.
Visit discovertheforest.org to find the closest forest or park to you.
This is KETN, standards-based instructional programming for educators and K-12 learners, a service of your Kern County Superintendent of Schools office.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, California Resources Corporation, Southern California Edison, Kern Schools Federal Credit Union, Panama Buena Vista Union School District, and the San Luis Obispo County Office of Education, with additional production assistance provided by the supporters of education in Kern County and throughout the state of California.
We are live today at Berkshire Elementary School, and we are here to do
Well, good afternoon and welcome to Do the Math. I'm Michael.
And I'm Chuck. Give us a call with your math questions. We're here until 5:30 in Bakersfield. You can call us at 636-4357. San Luis Obispo and the outlying areas, you can call toll free at 1-866-636-6284. You can email us questions at dothemath@kern.org. You can watch the show online at dothemathonline.net. And we're on social media. You can see us on Facebook and Instagram, Twitter, and on YouTube.
All right, lots of different things going on.
Yes.
And we were just talking about this momentarily, about baseball season is now at the good part for a lot of people that usually don't watch baseball because the playoffs are starting.
That's right.
And your team is in the playoffs.
Absolutely, Giants.
That's right. And I'm going against my New York team, the Mets, and I'm actually rooting for the Giants.
Got to go with Mad Bum
win that one
for the
game.
Giants tomorrow.
Did you know that today is Trucker Day?
I didn't. I thought it was Taco Day.
Well, it's Trucker Day because it's 10-4.
10-4, got it.
See, I heard that
Good,
on
buddy.
the radio somewhere. I was like, all right, yeah, 10-4, all right, it's Trucker Day. Anyway, it is a big day. We do have phone tutors available until 5:30. A lot of screaming eagles out there at Berkshire Elementary.
Yes.
I believe they're the Eagles.
Eagles.
I don't know if they're
Okay.
screaming eagles, but they were at that moment. We have a very special guest in studio and a lot to get to, but first, before we do all of that, let's first take a look at today's Math in the News. So there was an article about copyright pages and the numbers that are on them.
Okay.
Okay, so I pulled up a couple of pages from books with, it's just got a lot of numbers on there right now. We can see that this book was published, copyrighted 1978, University of Chicago. And then there's the numbers down here. And a lot of people, well, what's up with those numbers? So we found another one. And we can see
Lots of numbers.
the copyright is 1981, but these numbers are quite different from the last one.
Right.
Right, so these ones are going 15 all the way back to 2, but don't include the 1. And the other ones were pretty weird also. And then I found another example, and this just goes 10 back to 1. So there's a lot of different things going on here. And the article that I found talks about the numbers on these copyright pages.
Okay, good.
While different publishers use different conventions for these number lines, generally speaking, the smallest number in the line indicates a book's printing. So if it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, it's a first printing.
Okay.
So they're including the number 1. If the number 1 has been removed, so it's 2, 3, 4, 5, 6, 7, 8, 9, 10, it's the second printing.
Okay.
So if the number 3 was removed, it would be the third printing. The reason they remove a number instead of just changing a number has to do with the way publishers have historically printed the books. In offset printing, you can relatively easily remove something from the printing plate, but adding a number would require a whole new plate.
So that's why they have the numbers from 1 to 10, so they don't
They
have
can
to
just
add
remove
numbers. They
one,
just
right. So they
got
can
it.
remove it every time instead of making a whole new plate just for that
When
page.
printing used to be mechanical and
Right.
hard to do.
Then, depending upon the publisher, the number line might also indicate the year. So it might say 2, 3, 4, 5, 6, 93, 92, 91, 90, reveals that the second printing was done in 1990, and then once again, you take a number off each of those so that you can see what edition it is and what year
Right.
that printing happened. So I was like, all right, that's pretty cool. Those are sequences of numbers.
And interesting conventions that we still have, even though
Right,
they
yeah.
really don't have that problem anymore.
Antiquated, but still useful in the way it's
Right.
going. So I
Tradition.
figured, let's take a look at some number sequence. A sequence in mathematics can be a string of numbers that follow a pattern. The elements in a sequence are called terms. One of the simplest can be found in multiplication. So we have 3, 6, 9, 12, 15, etc. The pattern is to add 3 to the previous number to get to the next number. So I figured, all right, that's nice. Kids are looking at that going, all right, number sequences, I kind of get that, but I want to see some sequences. So here's some sequences. We have triangular numbers, square numbers, cube numbers, Fibonacci numbers. These are all sequences, and there are hundreds of other ones. And then it's simply try your own sequence. So, in studio with us right now, we've got Justin. How are you today?
Good, sir.
Have you ever seen triangular numbers before?
Yes.
Where have you seen those? Or can you tell me what the pattern is here? What's going on?
When you put them in the rows of dots, they'll make a triangle.
Right, exactly. So if you just make the dots, like if you put 1, and then underneath you've got the 2, and then together there are 3. And the next row you would have 3 on there, so you would have a 1, a 2, and a 3 to make up the total of 6. So you can see that, and you can see here you're also adding 2, add 3, add 4, add 5, add 6, and we can do it like that to figure out the numbers without having to actually make all those dots, right?
Right.
Have you ever seen square numbers or what's going on here?
Yes.
Okay, why don't you tell us a little bit about
The
that?
numbers multiplied by themselves.
Right. So 0 times 0, 0.
And geometrically, if those are triangles up on top, what can you do with square numbers? If you can make triangles out of those top numbers, what can you make with the square numbers?
Squares.
Squares.
There you go, all right? So 2 squared, 3 squared, 4 squared, and so on, right? What about cube numbers?
You can put them in cubes if you use them as dots.
And so we're going to go 1 to the 3rd power, 1 cubed, so it's 1 times 1 times 1. 2 cubed, 2 times 2 times 2. 3 cubed, etc., right?
Right.
Fibonacci numbers, have you seen these before?
Yes.
Explain a little bit about what you know about these numbers. What do you see in this sequence here?
The next number is the last number added by the number before it.
There you go. So 0 and 1, we add them together, we get 1. 1 and 1, we add them together, we get 2. 1 and 2, we add them together. See, we got that sequence right there. Now it says try your own sequence. What kind of a sequence do you think you would come up with?
Something like multiply by 3.
Multiply by 3?
Yeah.
Kind of like what we were doing at the beginning? Well, that's it. You know what? Anybody can make any type of sequence they want. And that is today's Math in the News. Number sequences and how we got to those from the copyright pages out of any book that you take a look at. 636-4357 is the phone number. We do have phone tutors available until 5:30, but in studio with us, I waved you up here to help me out with that. And Justin, why don't you let everybody know where you go to school and what grade you're in?
I go to Stockdale Elementary and I'm in 5th grade.
Everything going well in 5th grade?
Yes.
Nothing difficult yet?
No, not yet.
All right, well, I guess we're going to have to give you some difficult math problems today. How's that?
Sounds good.
All right, well, we'll see if you still say that after we give you the math problem. Anyway, we're going to go to the phones right now. And John, how are you today?
I am all right.
All right, what grade are you in?
I am in 6th grade.
All right, as soon as you're ready, let's hear the math problem that you're working on.
Okay. The answer I am working on is parentheses 12 plus 10 plus 8 plus 6 plus 4 plus 2 parentheses. Division sign.
Okay, so all of those are in parentheses, and then a division sign like the line and 2 dots?
Yes.
And you're gonna, because I'm gonna stop you for a moment, because if you keep writing this way, you're not going to have room. So instead of putting the division symbol like that, why don't you just draw a fraction line?
So is that
underneath
okay?
Everything you've got?
I'll do division by putting everything you're going to give me next underneath it. How's that?
Okay.
Okay, that's the same as division. Okay. And what do we have on dividing by?
Parentheses 6 plus 5 plus 4 plus 3 plus 2 plus 1.
And then plus 1 and in parentheses?
Yeah.
Okay. That's the problem, and you just have to solve that or work it out?
Solve it.
Okay. So what have you been doing? Have you been working with, well, let's see, we just talked about sequences of numbers with parentheses. How about this series of numbers that we add together? Have you been working with these?
Yeah.
Do you have a
actually,
trick for doing this, or do you just add these all up? What do you get?
So I got 42.
Pardon? You added
42.
you added the top together and you get 42?
42. Yes.
Okay. So did you just add them 12 plus 10 plus 8 plus 6 plus 4 plus 2?
Yes.
Is that what you did? Okay. And you got 42?
Yes.
Do you know there's another way of doing this?
Not that I heard of.
Well, if you add 12 and 2, what do you get?
14.
14. If you add 10 and 4, what do you get?
14.
14. And if you add 8 and 6, what do you get?
14.
And what's 14 plus 14 plus 14? Isn't that just 3 14s?
Yes.
And you know what that is? 42. So you could take 14 and multiply it by 3 because you had 1, 2, 3 14s. And you can get 42 that way also, couldn't you? All right, what'd you get on the bottom?
Okay, I added them all together.
And what'd you get?
I got 20, hold on, 21.
21. All right, so you added 6 plus 5 plus 4 plus 3 plus 2 plus 1, didn't you?
Yes.
There's a little, I don't want to say it's a trick, but it's a way you can do it and almost do it in your head. What's 6 plus 1?
7.
7. What's 5 plus 2?
7.
And 4 plus 3?
7.
How many 7s do you have?
3.
3. 3 times 7 is? 21. So that's a way of checking your work, right? Especially if you have a long list of numbers and you have big numbers, that might be a way of checking your answer. So top is 42. We've done it 2 ways, haven't we? The bottom is 21. We've done it 2 ways, haven't we? So what do you get for an answer?
2.
42 divided by 21? It's 2, isn't it?
Yes.
And something that you might notice in this problem that's interesting is, what's 12 divided by 6?
2.
And 10 divided by 5?
2.
And 8 divided by 4, and 6 divided by 3, and 4 divided by 2, and 2 divided by 1. Notice that all of those, even though they're separated by plus signs, they all give us a 2. But when you add them all up, you don't get 2 plus 2 plus 2 plus 2 plus 2 plus 2, do you? You get just 2 as your answer. Interesting, isn't it?
Yes.
That's the answer. Thanks for the call.
There you go. Nicely done, John, for that great phone call right there. We're going to send you over for a free meal. Our friends at Johnny Rockets and Lydia will be glad to see you. So congratulations on that. 636-4357 is the phone number. We do have phone tutors available until 5:30 on most Tuesdays and Wednesdays throughout the regular school year. Don't forget, if you call from outlying areas of Kern County as well as San Luis Obispo, the phone number is toll free at 1-866-636-6284. When you call in from San Luis Obispo, we've had kids calling in from Boron and a lot of outer areas today so far. But if you're calling from San Luis Obispo today, you will be getting yourself some free Doc Bernstein's Ice Cream Lab ice cream. You like ice cream, Justin?
Yes.
What's your favorite flavor?
Chocolate.
Chocolate? You know what? I think when we went over to Doc Bernstein's, we had a base of chocolate and we did something else to it. And it's going to come out pretty soon. And if you ever go over to the Central Coast, you need to look up Doc Bernstein's Ice Cream Lab, tell them you were on Do the Math, and see if they have that ice cream flavor for you that the math ones, all right?
Okay.
So as soon as it comes out, we'll let you guys know about it, and then you can go over and check it out. Sound good?
Sound good.
All right. Right now, we're going to go check it out with Berkshire Elementary and Mary Lou.
Thanks, Mike. We're here at Berkshire Elementary School, the ACES After School program, and I'm here with Fernando today.
Hi.
How you doing, Fernando?
I'm doing good.
And what grade are you in?
I'm in the 6th grade.
Ah, have you been here since kindergarten?
Yes, I have.
Have you just absolutely loved your campus here?
Yes, I have.
Gonna be sad when you leave?
Sort of, yeah.
Well, Mike was back in the studio talking ice cream. What's your favorite flavor?
I like plain vanilla.
Oh, just plain vanilla?
Yeah.
All right. Okay, now you said earlier that you have been on TV before.
Yes, I have.
And it was with the news. And you said something about pet adoption.
Yes.
Can you quickly kind of tell us what that was for?
The pet adoption?
Yes.
Yes. So they're having pet adoptions at a local adoption center. And what they did was they took a quick scan of all the dogs, and the little pound showed what they were doing. And they showed up a little quick scan of me and my sister checking out the dogs, filling out the papers, and stuff like that. And it was like really sad how we saw all the dogs just sitting there in the corner.
They wanted to be adopted.
Yeah,
didn't
they wanted
just
to be
makes,
adopted.
Makes you want to just take them all
Yeah.
home with you, huh? All right, well, let's look at this math problem that we have here. It's a word problem, obviously. So it says a school cafeteria has a restriction on the amount of sugary drinks available to students, which is a fact, I know that, at schools. Drinks may not have more than 25 grams of sugar based on this restriction. What is the largest size cola the cafeteria can offer to students? And we need to know in ounces. Now we have a chart started here. We have for 6 ounces of cola, the amount of sugars is 20 grams. The first thing we need to do is, can we simplify this? Because this is actually a fraction, isn't it?
Yeah.
Okay, can we simplify that fraction
Yes.
down?
To find the simplest fraction, you could divide the number either by itself or by a lower factor, I guess. Yeah, factor. And in this case, we could divide by 2,
Okay.
which would give us the fraction 3/10.
Okay, why don't you write 3/10 underneath it? Oh, here you go. I'll switch with you. Okay.
Thank you.
You're welcome. So that 3/10, does that represent if we have 3 ounces of cola, then we have 10 grams? Okay. What if we had 7 ounces?
7 ounces?
Yeah, let's put a 7 there. How can we determine how many grams? What are we going to multiply that by?
Multiply by
We're going to multiply,
2.
what do you think, by 2?
I guess, yeah.
Okay, because we have 3 over 10, right? So we want this fraction to simplify to 3 over 10. Let's try another one. Let's try 8. Let's throw 8 in there.
All right.
Let's see. Can we throw an 8 in there? Okay, is there one that we can do like 8 where it simplifies to 3/10? You think?
no.
No? Okay. Why don't we do this? Can we multiply both of these by 2 to make an equivalent
Yes.
fraction? Okay, we could do that too. So what is 6 times 2?
12.
Okay, so if we have 12 ounces of cola, we have how many?
40 sugar.
Okay.
40 sugar grams.
And let's go ahead and multiply this by, multiply this by 3. What's 6 times 3?
18.
Okay. Let's go ahead and multiply this by 3.
60.
Okay.
60 grams.
Now, what about 6 times 4?
24.
Okay. And 20 times 4?
We're going to get 80.
Okay.
80 grams.
And what about, we're at 6 times, let's see, 2, 3, 4, 5. 6 times
We're
5.
going to have 30 ounces.
And 20 times 5?
We're going to get,
100?
yeah, 100 grams.
There you go.
I got last there.
And last one is 6. 6 times 6 is?
6 times 6 is 36.
Okay.
36 ounces.
And 20 times 6?
We're going to get 126 grams.
120,
Oh,
right?
yeah, it's 126. No, 20, sorry.
There you go. And
Oh,
these are
sorry.
just fractions, right?
Yeah.
And if we actually simplify them all down, do you think we're going to get 3/10?
Yes.
Yeah, we are. Because they're all equivalent, aren't they? But again, now we need to look at the question again. It wants to know, we can't have any more than 25 grams. So what can the cafeteria sell to students?
They could sell at least 24 ounces of cola.
Okay, but let's see. But the sugars can't be any more than 25 grams. So if you said, what did you say, 24? But how many grams?
Ooh, we have 80.
That's 80 grams. Is that too much?
Yeah.
That's too
My
much.
eyes were sticking.
So what do you think? We need to go less than that.
Yeah.
Which one? We need something with 25 grams or less. Where do you think?
Maybe 6 ounces?
6 ounces? Yeah, because if we go to the 12 ounces, is that too much? That's too much, isn't it? So looking at this, 6 ounces, so we know they can sell at least 6 ounces, don't we? Because there's only 20 grams. But with 12 ounces, that's 40, isn't it? So let's go ahead and circle that, okay? There we go. All right. Yes, I know that schools, cafeterias have to watch the amount of sugar on drinks, huh?
I'm nervous.
We don't want a really sugary drink. You did a great job.
Thank you.
All right, Mike, back to you at the studio.
All right, thanks for that, Mary Lou. And Justin was saying his favorite sugary drink is Pepsi.
Pepsi.
Pepsi, right? You can't say Coke if you say Pepsi, right? Those two are like big feuds right there. Anyway, we do have phone tutors available until 5:30. We've got a couple of other phone calls to get to, but first we're going to make Justin do a little bit of work. So head on over to the board. This is a problem that was emailed to us by a 4th grade student, and the problem was 43 times 6. And they said we have to use multiplication, but they want estimation. Now the thing is, I'm going to have Chuck work with Justin.
Yeah.
When you just say we need to estimate it, there are a couple of different things we can do. So take it away, boys.
Right, so let's start over here. And so how can we estimate, instead of actually just multiplying 6 times 43, how do you estimate something like that?
You can do 40 times 6.
Yeah, so you can say 43 is pretty close to 40, so let's write that down here. Write down 40 times 6. And so we just rounded off that 40 to the nearest tens, right? Because it's a
Right.
nice round number. And what do you get if you multiply 40 times 6? This is easy to do in your head.
240.
You can do that in your head, can't you? So
Yes.
estimating should be pretty easy once you round it off. Now, how else could you round this off? So we have 43 times 6. You rounded off to 43. What could we do with that 6? What's that close to?
5.
It's close to 5, because that's a nice number to multiply by. So you could go round that 43 off to 40 and do it times 5. That's another estimate. So it's pretty close to 200. Now you rounded down to 5. What if we did it by tens, like we did this by tens? What if we did that by tens? We could have a 40 on top, and what would we have on the bottom?
10.
10, because that's pretty close to, well, it's more than halfway to 10. So another estimate could be 40 times 10, which is, again, real easy to do in your head, isn't it? It's just
Right.
400. Let's see, is there any other we could round that off to? So let's see, we rounded off the 40 and left the 6 alone. What if we left the 43 alone and rounded off the 6? How about if we started with 43 on top and rounded that 6 up to 5? Yeah, and what's that? That one's not so easy to do in your head, is it? What's
No.
that going to be? So
215.
215. And let's do the same thing. We rounded it down to 5. What if we rounded that 6 up to 10 and left that as a 43?
$430.
430. So what do you think? Which one do you think is probably the best estimate of this?
40 times 6.
Let's see. Let's go ahead and multiply that out. Go ahead and multiply 43 times 6, even though it didn't ask him to do it in this problem to estimate. Let's see which one of these, we've got, what, 5 different estimates here. Which one do you think is closest? So let's see, 240, 200, 400, 215, 430. So it looks like your first one was pretty close. We were only 18 off. This is way too big, right? 430.
Right.
Right? So some good estimates, and again, depending on the problem, you'd get one of those answers.
All right, there you go. Nicely done. And thank you for that emailed question from that 4th grade student. 636-4357 is the phone number. We do have phone tutors available until 5:30. Right now, we'll go back to the phones. And in just a moment, we're going to get back to there. So what we're going to do is we're going to tie in some different shapes and the number of sides. So right now, we're going to go back to Michael from Castle. How are you today?
I'm good.
And what grade are you in?
I'm in 6th.
All right, as soon as you're ready, let's hear the math problem that you're working on.
Okay. A pentagon is an 11-sided polygon.
So what was that, hen? Did you say hen?
Yes.
Hen decagon?
Yes.
Okay. Okay, that's 11 sides? All right. And what else do we have?
What is the product of the number of sides of a pentagon and a square?
And a square. So we want to multiply the two numbers that are the number of sides. So you've already given us the number of sides in a hendecagon. I'm glad I don't have to draw that. That's 11. And we just need to know how many sides in a square?
4.
4. So that's going to be 4 sides, isn't it? So you just have to multiply. Now, did they tell you that a hendecagon was 11 sides, or did you have to know that?
It told me that it was 11 sides.
But it didn't tell you that a square had 4, right?
Yes.
So that you needed to know that. So what did we need?
We needed to find the product of a pentagon and a square.
Find the product. So the question now is, what operation is product?
Product is multiplication.
Right, product is multiplication. So you need to know, right, the difference between a product and a sum and a difference and a quotient, right? So this is the answer to a multiplication problem. So what two numbers are we going to multiply?
11 and 4.
So let's go ahead and do that. Let's go ahead and multiply 11 times 4. That's probably the easiest part of the problem, isn't it? 11 times 4. And what's your answer?
40.
Write it down.
44.
So I'm pretty sure that they knew that you could multiply 4 times 11. So the things that you really needed to know in this problem is how many sides in a square, right? And you needed to know what a product was. You didn't want to add those two numbers. You didn't want to subtract or divide them. You wanted to multiply. So that's really a good problem because as easy as the work was to get the answer, you still had to know those two things in order to do it. Right? Thanks for the call.
All right, nicely done. And Michael, do remember we have phone tutors available until 5:30. We'll be back with more right after this. Today we're at scenic Fraser Park, home of El Cajon School, and today we're here to... Once again, we're at El Cajon School, and right now we've got 8th grade student Sadie with us. How are you, Sadie?
Good, how are you?
I'm well myself. Go ahead and read that problem for us.
That is 3x plus 5 equals 18.
What do you think I would like you to do with that problem?
First, we would need to do order of operation, which you would minus the 5, which is opposite math. Okay.
But what do you think I'm eventually looking for?
To solve for x.
To solve for x?
Yes.
But I don't want you to do that. I want you to tell me what 6x will equal.
6x?
Yeah. So first of all, before you can tell me what 6x is equal to, what do you have to find out first? What x is equal to.
Yes.
So go ahead and go through this problem and solve for x first.
Okay. So first, we would do opposite math, and you'd cross that out. 13. I'm going to do it like this. 3 goes.
So for everybody watching right now, you went -5 because you said you were going to do the opposite, right? So the opposite inverse of addition is subtraction. So you're going to subtract 5 from both sides because it's kind of like a balance, right? Whatever you do to one side, you have to do to the other side. So we went ahead and did that. So you you subtracted 18, took away 5, you got 13. So now you have 3x is equal to 13.
Yes.
Okay? And we want 6x. Okay? So what are we going to do here? Here, instead of doing what you did there, okay, because I saw what you were doing there, okay, and I said, yeah, let's figure out what x is, all right? So take a look at this. 3x is equal to 13, okay? So if I have 6x,
Equal to 13.
well, if 3 is 13, what is 6? What did we do here?
We multiplied
By what?
by 2.
So what do we do here?
Multiply by 2.
So, see, the question was, what does 6x equal to? Because what I let you do is go ahead and say, all right, we're going to solve for x first, and then go ahead and multiply by something else, but you don't even have to go through that whole process. See, because once we get to 3x is equal to 13,
Yep.
we want to know what 6x is.
Okay.
So, do
And
you
so
see how
you-
we just simply did that?
Yeah.
So if I said this, I want to know what 9x is.
And you would multiply 26 times 2.
Well, instead
Well-
of,
No, you would just do,
because we went 3 times, if we just went from 3 to 9, what do we do?
then that was 3 times 3.
Right.
And so 9 times 3.
So now we're going to go 13 times 3 is going to give us,
Can I do it out? 39.
there you go. So you see how that pattern goes?
Yeah.
See, if 3 is 13, 6 is 26, 9 is 39, we don't have to do all of the other division. If I said 12x, now instead of multiplying, what else could we do? Because here I'm just increasing by what?
By 3. No.
By 13s, right?
Yeah.
Is
So
that the bell
then-
for you to go to class? I'm only kidding. So if we're just simply adding 13 every time, what do you think we're going to do?
Add 13 again.
Okay, so add 13 again, what do we get?
52.
52. All right. So, because there are going to be problems where it says, I want to know the value of 6x. If you know 3x is 13, simply double this. You get to 26 and you get to the problem a lot easier. All right? Sadie, nicely done.
Thank you.
All right. And once again, a big thanks to all of our friends at El Tone School up there. We do have phone tutors available to that came out really quick, didn't it?
What time is that?
Right over at 5:30, as always on Tuesdays and Wednesdays. But before we get back to the phone calls and making Justin do more work in studio, we're going to first of all go out to Berkshire with Mary Lou.
Thanks, Mike. We're back here again at Berkshire Elementary School, ACES After School Program, and I'm with Selena. Hello. How are you doing today?
I'm doing good.
And what grade are you in?
6th grade.
6th grade. What's your favorite thing about 6th grade?
My last year here at Berkshire.
Oh, that's really special, huh? Make sure you have a fun year, right? All right. Okay, so Mike has been talking all day about sequence. We have something that's a sequence, don't we? It's a ratio, but it's really kind of a sequence, isn't it? So it says Selena solves 3 math problems in 4 minutes, and we need to complete this table, right? So yeah, it is a sequence, isn't it? So we know that she solves 3 problems in 4 minutes, and that's what the information we need, right? So here we have number of questions, which are 3. Number of minutes, Selena, what are we going to put there?
4.
Okay, let's put a 4 there. Now here we have it started. If we have 6 questions, then how many minutes is it going to take us? 8. How did you get 8?
Well, 4 times 2 equals 8.
Exactly. So we're just timesing by 2 here, aren't we? That's our pattern. Okay, let's put 8. So here we went 3, 6, What do you think we're going to put here?
9.
9. And 3 times what is 9?
3.
Okay, I'm going to let you put the 9 there. And what are you going to put in this box?
12.
Okay, because 4 times what?
4 times 3 is 12.
Exactly. And again, we could clearly see our pattern because here's times 2, here's times 3. This is going to be times
4.
Okay, go ahead and fill in those boxes for us. And then, so if this is times 4, this is?
Times 5.
All right. So 3 times 5 is?
15.
And 4 times 5 is?
20.
There you go. So what's next?
Times 6.
I'll let you write that up there. Okay, so 3 times 6 is?
18.
And 6 times 4?
24.
Instead of keep saying times, which we know we're going to go times 7, and we know we're going to go times 8, times 9, and times 10, can you just quickly do this with a pattern of adding 3? Okay, let's go ahead and finish off our number of questions and tell us what you're putting in there.
Okay. 3 times 9 is 27, and 3 times 10 is 30.
Okay, now let's go ahead and finish off our number of minutes. And we have our 4 times 8, which is?
32. And 4 times 9 is?
Just add 4, yeah, add 4 to that.
36.
There you go.
And then 4 times 10 is 40.
And another great thing about this, okay, these are all ratios, aren't they?
Yes.
They're all fractions. And if we actually simplified every single one of these, Selena, guess what answer we would get if I simplified all of them? What did we start with? 3/4. So every single one of these are equivalent fractions. And that's what a ratio is. A ratio is equivalent fractions, right? Equal fractions. Well done, well done. All right, Mike, back to you in the studio.
All right, thanks for that, Mary Lou. All right, we have some other phone calls to get to, but first we're going to put Justin back to work. Over to the board, young man. This is a problem you will do in 6th grade and probably in 7th grade and 8th grade, but since you're in 5th grade, we're going to give you a head start on it. Because this is a problem that someone emailed us, so we need to go ahead and work on it today. 2k, open parentheses, 4 minus 3k, close parentheses, minus, open parentheses, a negative 3, close parentheses, plus 2k. And Justin, what you need to do is you need to simplify that expression.
There's a lot to do in this problem. We've been seeing some of these with simplifying expressions and then also some equations. But do you know what we're going to do to start this problem?
This part.
Yeah, so let's do this first part, and you can write it down here. We're going to do this set of parentheses, and that means we're going to use something called the distributive property, right?
Right.
So we're going to multiply 2k times 4. What's 2k times 4?
8k.
Yeah, you know that 2 times 4 is 8, so let's go ahead and write that down. That's 8. And the variable just stays with it. Okay, now we're going to multiply 2k times 3k, and we're going to subtract it, aren't we? Or some people will say 2k times negative 3k. But let's go ahead and go 2k times 3k, that's what?
6k.
6, so that's 6.
6k.
And it's k times k.
K squared.
K squared, we talked about squared numbers, these are raised to the second power. So let's go ahead and write that down. Minus, so we're going to go ahead and write down that minus because it's subtraction, and 6k squared. All right, so we've gotten rid of these parentheses and got 2 terms. Now we've got to get rid of these parentheses, but we're not going to use the distributive property because we don't have any operation here. We just want to take, have you worked with negative numbers?
No, not yet.
Well, so what we're going to do is we're going to work with a negative number, and I'm going to ask you a question. What's the opposite? What do you think is the opposite of negative 3?
Plus 3.
Plus 3, or positive 3. So let's write that down. Instead of minus a negative, we're going to write plus a positive 3. And then let's go ahead and write down that plus 2k. We're not going to do anything with that. We're just going to rewrite it. So the first step in doing these problems that we've been doing for the 6th graders that have been calling in is get rid of all of the parentheses. That's pretty easy, isn't it? Yes. Here's the second step. We're going to combine like terms. Now, what do you think like terms means?
Related terms. Related terms.
So related terms, right? They're going to look alike or they're going to be related. So you notice that some of these numbers have a number and a k. Some of them have a number and a k squared, and some of them have just a number. Which ones look like they're related or like terms?
8k.
8k and
2k.
2k. They have a number and just a k, not a k squared. So those are the two numbers we're going to combine. And you notice we're going to combine them. We're going to take an 8k and a plus 2k. What do you think that is?
10k.
10k. So write down 10k. There's only one 6k squared, so let's write down minus 6k squared, because there's no other like term there, is there? And then there's nothing, so I sometimes can do this, right? Underline that twice. And then the 3 is also all by itself. I'll underline that 3 times, and it's all by itself, plus 3. And so if you simplify this expression by removing parentheses and combining like terms, you'll get an answer of 10k minus 6k squared plus 3. Or sometimes they'll have you put it in order. We talked about k and k squared and k cubed with cube numbers.
Yes.
A lot of times the answer they'll put it in order, and they'll put the k squared term first, then the k term, and then the number. And you notice that the minus went along with the 6. That 10 is positive, isn't it? So we had to put a plus in front of it, and the 3 is positive. So you'll also see an answer something like this. And there is your 6th grade work for today. Right?
All right, well done right there. Hey, come on over, Justin, because you've done a 4th grade problem sent in by email, and now a 6th grade problem done by email. So we're going to go to the phones right now with Daniel from Stockdale. How are you today?
Good.
And you're a 6th grader?
Yes.
All right, because Justin said he might know you, so let's go ahead and hear what problem you're working on.
Okay. 2.3n minus 3.2 plus 4.1 equals negative 6.
And the directions for this are to solve?
Yes.
So you got to solve for x, right?
Yes.
Okay, so how do you solve for x?
You try to get n on one side and
Oh, I'm sorry, is this an x or an n?
n.
X?
N.
Oh,
Sorry.
n, I'm sorry. I heard x. So this is 2.3n
Yes.
minus 3.2 plus 4.1 equals negative 6. And so when you're all done, however many steps it takes us, right? At the bottom down here somewhere, we're going to have n equals, and that's going to be your answer, right?
Yes.
All right, now what steps do we have to go through to get that? How do we get n all by itself?
Take away 3.2 and 4.1.
So how do you get rid of those? Well, let's see.
You would, for 3.2, you would add 3.2 and it would cancel it out.
So we're going to add 3.2 to both sides?
Yes.
So we're going to do these separately. Okay, so let's add, let me do this. Add 3.2 here. And add 3.2 here?
Yes.
Okay. So you said it cancels it out because what's negative 3.2 plus 3.2?
0.
0. That's why they cancel out, right? So on this side, looks like we have 2.3n plus 4.1 equals, now what is negative 6 plus 3.2?
Negative 3.2.
Negative 3.2?
Yeah.
Okay, so let's see. That's 6.0. If I'm going to add or subtract these, I've got to make sure they have the same number of decimal places, right?
Yes.
And what do you do when you have one number negative and one number positive? Sounded like you subtracted them, right?
Yes.
So what's 6.0 minus 3.2? It's not 3.2, is it?
No, it's 2.8.
Yeah, because what did you have to do?
You had to borrow.
Borrow and make that a 10, and there's your 8, right?
Yes.
And there's your 2, and then we just bring that decimal straight down. And you said negative?
Yes.
Why is it negative?
Because the negative number is greater than the positive.
Yeah, the big number is negative, so the answer is more negative than it is positive, isn't it?
Yes.
All right, so we've simplified the problem a little bit, but we still got a 4.1 and a 2.3, don't we?
Yes.
So what's next?
We have to get rid of we have to subtract 4.1 on each side.
Okay, so we have a plus 4.1, we want to get rid of it, so we do the opposite, you said, and that's minus a 4.1?
Yes.
And let's see, we'll minus a 4.1 over here.
Yes.
Again, what's 4.1 minus 4.1?
0.
Get rid of it, we made it 0 again. So on this side, we have 2.3n equals, now what's negative 2.8 minus 4.1?
Negative 6.9.
Now how'd you get 6.9?
Because when you don't subtract negative, because they're both negative, they create a bigger negative.
So
Like
when you
adding,
when you add two negative numbers together, which is what we're doing, right?
yes,
You get a more negative answer, don't you?
yes,
Right? So you got to remember, two negatives make a positive when you're multiplying, but
Yeah.
two negatives added together give you a more negative number. And you said just add them together, that's 6.9, right?
yes.
All right, so we've gotten rid of 1, 2 of the numbers. We still got to get rid of that 2.3. How do we do that?
You don't because you're solving for n.
Yeah, so we want the n by itself. So how do we get rid of that 2.3?
Divide by 2.3.
Yeah, okay, now why do you divide?
Because you will get a smaller answer.
Well, let's see. Up here, we were subtracting 3.2, so you added, right?
Yeah.
Because the opposite of subtraction is addition, right?
Addition, yeah.
Here we were adding a 4.1 and you subtracted because the opposite of addition is
Subtraction.
subtraction. Here you said we're multiplying, right? 2.3 times n. What's the opposite of multiplying?
Division.
Division. So I'm going to show division as a fraction like this, divided by, right?
Yeah.
And let's get rid of that 2.3 by dividing by 2.3.
Yes.
Now, what's 2.3 divided by 2.3? What's any number divided by itself?
1.
1. Up here we got a 0, didn't we, to cancel out the 3.2. Here we got a 0 when we canceled out the 4.1. But here when we divide, we didn't really get 0. We got 1n, didn't we?
Yeah.
But what's 1n?
N.
It's just n. I just lost it. Did I go back a page, Mike? I did. I got it. So we'll just erase that 1 and just know that 1n is just n. And now what's negative 6.9 divided by 2.3?
It would be 3.3.
Well, let's see. I'm going to take 6.9 and divide it by 2.3, right?
Yes.
So how do we divide by a decimal?
I haven't learned that yet.
Yeah. We don't like dividing by decimals, do we?
No.
So instead of dividing by 2.3, we're going to divide by 23. Right?
23, yeah.
Remember, we moved that decimal point to make it a whole number, right?
Mm-hmm.
If we move that decimal point, we have to move this one too, don't we?
Yes.
And bring it straight up. Now, here's the question. You ready?
Yeah.
23 times what is 6.9?
23 times 3 is 6.9.
Yeah, if you go 23 times 3, you get 9. You get 69, don't you?
Yeah.
So 23 goes into 69 3 times.
Mm-hmm.
with no remainder. So what's 6.9 divided by 2.3? You got to be careful. 2 divided by 3 is 3. 9 divided by 3 is 3. But we're not doing 2 divisions. We're just doing 1 division, aren't we?
Yeah.
So what's our answer down here?
10 equals 3.3.
Nope. What's our answer here?
3.
3. It's just 3, isn't it? Positive or negative?
Positive.
Negative divided by a positive is?
Negative.
Negative. If the signs are different, the answer is negative. So here's where you got to be careful. There's our answer, but we can't divide both of these separately. It's 1 division problem, isn't it?
Yes.
And so our answer is -3, which means if you put that back up into the original problem, it should work. So I'll leave the check to you with all of those decimals, but be careful when you multiply and add and subtract.
Okay.
All right, nicely done. Daniel, you still online with us for a moment?
Yes.
All right, well, congratulations, because right now you've got yourself a free movie ticket to the Friends at Maya Cinemas. So you'll be able to go check out a movie. Not a bad deal, huh?
Yeah.
All right, we do have phone tutors available until 5:30. A great problem that was, because I know there are students that see the 6.9 divided by 2.3 and they go 3 and 3 and
Very-
put 3.3.
Very tempting, yes, very
And
tempting.
as we saw, it's not 3.3, it is 3. So a great problem right there. Right now, we'll go back to the phones. Student from Reagan. Aditya, how are you today?
I'm good.
And your grade is?
6th grade.
All right, as soon as you're ready, let's hear the math problem you're working on.
I'm good.
So just read the problem when you're ready.
Oh, so it's a complex problem, but I'm just going to make it easier. The number 5040 is important. The number 5040 is important because it's divisible by all the integers from 1 to 12 besides 11. However, there is an integer less than 5040 with the same property. What is this number?
All integers
Except 11.
except 11. Okay, and you said there's another one,
Yeah, there's another one.
and it's less than 5040?
Yeah.
Okay.
And you have to find that number?
Yeah.
Okay. So obviously
so-
you're going to need to know divisibility rules.
So you know it's divisible by, I'm going to write them all down. You ready? I know it's divisible by 1, but 2, 3, 4, 5, 6, 7, 8, 9, 10, not 11, and 12? Did you say up to 12?
Yeah.
So it's divisible by all of those, okay?
Yeah.
So let's see, if it's divisible by 4, isn't it divisible by 2 twice?
Yes.
Okay. And if it's divisible by 8, isn't it divisible by 2 3 times?
Yeah.
So let's take that smallest number right there, and what's another number smaller than 5040 that's divisible by 2 and everything else? What would you have to do to 5040 to get that number?
To
Well-
me, to find that number, I just found the smallest common multiple between 1 to 12 besides 11. That's what I did.
Okay, I'm sorry, let me ask you again. The problem is asking for the smallest number that's divisible by all of those, or a smaller number?
A smaller number.
A smaller number, okay. So here's, what did you do? Did you use all of those numbers to find that?
Yeah.
Let me show you a
So-
shortcut, I think.
What?
Let me show you a shortcut, okay?
Okay.
What's 5040 divided by 2?
2,520.
2,500, you did that pretty quick. You must have done that already, right?
Yeah.
All right, so 2,520, let's see. Is that number still divisible by 2?
Yes.
It is, isn't it? Because it's even. Is it still divisible by 3? Yeah, we didn't take out a 3, did we? Is it still divisible by 4? And by 5, and by 6, and by 7, and by 8, and by 9, 10, and 12?
You've got about a minute to get as far as you can.
I think that's probably a smaller number that's divisible by all of those numbers. Is that right?
Wait, let me check.
And is that your answer?
It is.
Is that it?
Yeah.
And we're done. And that was a shortcut. And we're done. Thanks for the call.
See how easy that was, Aditya? Are you still online with us?
Yeah.
Okay, well, you know what? Because that was a great problem, because I know that there were some people going, all right, well, how are we ever going to find this number? That was a wonderful problem, so we're going to send you over to Johnny Rockets for a free meal. So congratulations on that. 636-4357 is the phone number. We do have phone tutors available until 5:30, but right now we have one more time to head on out to Berkshire with Mary Lou.
And we are back here at Berkshire Elementary School, ACES After School program, and I am here with Genesis. Hello.
Hello.
And what grade are you in, Genesis?
I'm in 5th grade.
Okay, what's your favorite thing about 5th grade?
My most favorite thing about 5th grade is mostly math and reading.
Oh, yay. That's a good thing to have favorite of, isn't it? Okay, well, we have a math problem behind us, don't we? And it involves reading, doesn't it? Your 2 favorite things. Okay, so it says a baker was going to arrange into rows of 28. The baker divides 432 by 28 and gets a quotient of 15 with a remainder of 12. We need to explain what the quotient and remainder represent. Well, first of all, do we need to make sure that the baker divided this correctly?
Yes, we do.
Okay, so he has 432, okay. Where does 432 go when we're dividing? Does it go outside or inside?
Inside.
Okay, let's put that inside, and that's actually called our dividend, okay? It's always our first number, so let's put 432 in the house, okay? And what is he dividing by?
28.
By 28. And the 28 is called your divisor, and that is our second number, and it always goes outside, correct?
Correct.
Okay, now we need to divide this. So let's think, 28 goes into 43 about how many times? Well, he said 1, okay? Because he said 15, so we're going to double check. Do you think about 1? Yes? Yeah. Because let's go with 1 and try it out. So let's put a 1 up there above the 3. Let's make sure we line it up. There we go. Let's put it above the 3. There you go. So 1 times 28 is?
28.
Okay, let's put 28 and we're going to subtract. So obviously that's going to be a 13 and we need to borrow, don't we?
Yes.
Okay, 13 minus 8 is?
5.
Okay, bring down your 5. And 3 minus 2 is?
1.
Okay, put your 1. And then bring down our 2. Okay, now they said 5, so we're going to put our 5 here, right?
Mm-hmm.
So 5 times 8 is?
5 times 8 is 40.
Okay, let's do our 0. And then 5 times 2, we know 10 plus 4 is?
5 times 2 is 10 plus 4 equals 14.
Okay, put your 14. But that's okay. Put your 1 and your 4. There, you're good. There you go. Okay, now we know that, yes, if we subtract, we have 12. He's correct. What does quotient mean?
Quotient means the answer of the division problem.
And a remainder is the?
A remainder is an extra numbers from the division problem.
Perfect. Good job. All right. Back to you, Mike, in the studio.
All right, you know what? We've only got a moment left, so what we're going to do is figure out who's going to see the Bakersfield Condors. Justin, put your hand in there. Grab one of those papers, and we'll see who the lucky recipient is. And who is that?
Genesis.
Genesis, a 5th grader from Berkshire. So Genesis, congratulations. You're going to see the Condors. There she is. Hey, until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, California Resources Corporation, Southern California Edison, Kern Schools Federal Credit Union, Panama Buena Vista Union School District, and the San Luis Obispo County Office of Education, with additional production assistance provided by the supporters of education in Kern County and throughout the state of California. Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, California Resources Corporation, Southern California Edison, Kern Schools Federal Credit Union, Panama Buena Vista Union School District, and the San Luis Obispo County Office of Education, with additional production assistance provided by the supporters of education in Kern County and throughout the state of California.
We are live today at Franklin Elementary School, and we're here to
Well, good afternoon and welcome to Do the Math. I'm Michael.
And I'm Chuck. If you have math questions, you need help in your homework, you're getting ready for a test, give us a call here in Bakersfield at 636-4357. There's a toll-free number for the outlying areas such as San Luis Obispo. You can call at 1-866-636-6284. You can email us questions if it's easier at dothemath@kern.org. You can watch the show live online at dothemathonline.net. And we're on social media, Facebook and Instagram, Twitter, and YouTube.
I figured I'd just hold up that Doc Bernstein's ice cream thing while you were going through that right there. It'll take a little bit of time.
Yes.
Right. Anyway, we have a full slate of programming to get through today. We have a couple of phone calls waiting. We have a special guest in studio. We'll head back out to Franklin. But first, let's take a look at today's Math in the News. Now, first of all, welcome back.
Oh, thank you.
I mean you missed a day.
Just took a day off, that's all.
And it was nice that we had Yost come in and fill in for you that afternoon. And Yost had a great time down here. And
Oh,
I think
good.
he's looking forward to doing some more math. So I said, Yost, whenever you're ready, you come on down and we'll put you right at the end of the table and get busy and do some more math.
That's
so
good.
anyway, welcome back. And your team is still in the playoff hunt.
Yes, I've got my Giants shirt on.
Oh, underneath?
yes,
Okay, so San Francisco is still in the playoffs. And we're right in the middle of football season. It's underway, and things are kind of settling as far as the standings and stuff like that go. So I figured, I was looking through the paper the other day, and I figured, well, let's take a look at one of these, because we usually do box scores.
Right.
At one point during the year, and we usually do baseball box scores, but I figured let's take a look at a football one
Because
today.
I can't think of a sport with many more numbers and stats than baseball.
Right.
There's a stat for everything.
And every year they make up new ones.
That's
There's
right.
always something new added to baseball every year. But anyway, here's one from this past weekend when Buffalo and the Rams played. And first of all, what they do is they break it down by the score by quarters. And then in each one of the quarters, you can see what happened as far as who scored, the time, the score, and things like that. So then you can keep on going down. So there's all four. And then I figured, all right, the team stats. So then you can see how many first downs, the total net yards, the rushes, the passing, sacks. And there are many more that go into this, but those are the ones that most people are looking at and the most common stats that people are looking at. So then it's like, all right, let's go down to the individual ones. And those, once again, you can see, all right, well, I know how the team did, but an individual player, I'd like to see how they did, so they have the stats on that. So I was figuring, all right, that's nice. Who does all of that? So there's a team of statisticians that take care of all of that work.
Yes.
So I figured let's go ahead and take a look at what a statistician does.
Someone's got to crunch all those numbers and keep track of them and be able to find them and be able to use them.
And manipulate them and things like that. So
Exactly.
they use statistical methods to collect and analyze data and help solve real-world problems in business, engineering, the sciences, or other fields such as sporting
Sports,
events.
which
Okay?
is not a real world problem, but okay.
That's going on, so we'll count it as one. So then it's like, all right, so that's what they do, and we see some of the numbers that they work with, but what's the important number? Meaning, what do they make?
Right.
All right. So the mean annual salary, so the average for students that aren't familiar with what mean is, and we can see these are for 2015. In the United States, the average was around $84,000. However, based on where you are in the United States, it will increase. Being Northern California
Yes.
is the place to be if you have a nice firm or whatever that you're working for. Also, the federal government, I'm sure, is right in there. Washington, D.C., you can see is, about more than 20,000 more
Yeah.
than the national average. So a statistician can make a pretty nice living if what you'd like to do is work with numbers and things like that. So I found one last cartoon, and we can take a look at this right now. So it says fields arranged by purity. So we've got a sociologist, and a psychologist says, well, sociology is just applied psychology. The biologist, psychology is just applied biology. The chemist, biology is just applied chemistry. The physicist, which is just applied physics, it's nice to be on top. Then the mathematician all the way over on the end. Oh, hey, I didn't see you guys all the way over there. So that's where the mathematician is, this guy thinking the physicist.
Arranged by purity. I like that.
Right. So there it is, and that is today's Math in the News. 636-4357 is the phone number. We do have phone tutors available until 5:30 on most Tuesdays and Wednesdays throughout the regular school year. And we are here to help you out with your homework, as Chuck said, if you're getting ready for a test, maybe prepping for something coming up.
Maybe you've been absent, you've got makeup work to do.
Right. So there's a lot of different things that we're here to help you out with. We've also got Sean in studio. And Sean, why don't you let everybody know where you go to school and what grade you're in?
Oh, I go to Hart School, and can't remember.
What grade are you in? You know what grade you're in.
I'm in 6th.
There you go.
Yeah.
So Hart, home of the Hawks, correct?
Mm-hmm.
And how long have you been at Hart Elementary?
Since I was in kindergarten.
So since you were in kindergarten, so you've been there a long time. You're getting ready to leave next year.
Yeah.
So you're at the top of the food chain, so to speak, at Hart right now. Have you guys been to Camp Keep yet this year?
No.
Do you know if you're going to Camp Keep?
Yes.
So have you learned anything about that yet, or is it still a ways
we
off in the
haven't
distance?
really done anything with it.
Okay,
Like,
so you're probably going in the spring then.
yeah.
Well, I can tell you one thing. A lot of the students that have been on the program that are older than 6th grade have always said that one of the greatest things about 6th grade was going to Camp Keep. So that's a little something to look forward to, all right?
Yeah.
Okay. 636-4357 is the phone number. We're going to go right to the phones right now. A student from Old River. Samantha, how are you today?
I'm good.
And as soon as you're ready, let's hear that math problem that you're working on.
It's 4n minus 11n equals 105.
So make sure he's got that written on the board correctly, and then I think you guys can start.
I think I caught up with you. 4n minus 11n equals 105. Is that right?
Yes.
Okay. So it says to solve the equation, right?
Yes.
So what does it mean to solve an equation?
It means to make it so on one side it's an n and on the other side it's a number.
So when we're all done down here, we should have n equals and we should have our answer, right?
Yes.
All right, so let's see what we have to do. How do we get n all by itself? What's our first step in this equation?
We have to, so because the 11n is a positive, or I mean a negative, you have to put a positive number to make it so the 11 goes away.
Okay,
Oh, wait,
so
no.
we could do that.
N, so you have to add the n together.
We can do what you said, but because we have like terms, right, we can simplify.
You have to add them together.
Yeah, before we even try to solve it, we can try to simplify it. As an example, if we had parentheses in here, or in this case, like terms, we can make it easier. So let's take 4n minus 11n, and what do we get?
So because the 11n is a negative, you have to add 4 to you have to subtract 4 from 11.
So what's 11 minus 4?
7.
So that's going to be 7n. Is it going to be positive 7n or negative 7n?
Negative 7n.
Why negative?
Because the 11 is negative and 11 is bigger than 4, so it has to be a negative.
So the 11 is bigger than 4, so my answer is going to be more negative than it is positive, right? We could think of this as a positive 4n and a negative 11n, and you get more negatives than positives. So that's a really good one step to combine like terms. And we haven't done anything with that 105. All right, so we've got just one term now, but we've got more than just the n. We got to get rid of that negative 7. How do we do that?
We add a positive 7.
Well, let's see. Let me ask you, what does that negative 7n mean? What operation is being done here? Adding, subtracting, multiplying, or dividing?
Subtracting.
Well, it's a 7n. What does 7n mean?
So I think what it means is that you have no 7 n's and you owe like 7 n's.
Right, but when you have a number and a variable next to each other, what operation is that?
Multiplying?
Yes, it is, isn't it? So we know that this is negative 7 times n, isn't it? So what we have to do to get rid of that negative 7 is undo that multiplication. What's the opposite of multiplication?
Division.
Division. So I'm going to divide, and I'm going to show division as a fraction, right? I'm going to divide both sides of that equation by
7.
the number we're trying to get rid of. Not just 7, but negative 7, isn't it? So we want to cancel out that multiplication by dividing by that number, but since this is an equation, whatever we do to one side,
We have to do to the other.
have to do the other. We have to keep the equation balanced, don't we? All right, so I'll do the easy part. Negative 7 divided by negative 7 is 1, isn't it? That's 1n, but I don't need to write 1n, do I?
You just need to write n.
1n is just 1n, isn't it? And what's 105 divided by negative 7? So it's a pretty easy problem to do in your head, or just work it out. What do you get?
So 105 divided by negative 7 is 15.
Pardon?
15.
15, right? So that's 15. Is it positive 15 or negative 15?
Negative 15.
And why is it negative?
Because a negative divided by a positive or a negative times a positive is always a negative.
Or in this case, a positive divided by a negative, right? If the signs are different, my answer is negative. So you got to be careful. Up here you said when the bigger number was negative, the answer is negative, right? But here the bigger number isn't negative, is it? It's only negative 7. But doesn't matter how big the numbers are. If the signs are different, the answer is negative.
Okay.
That should be our answer. Now, do you have to go back and check your answer?
Yes.
So let's see. What's 4 times negative 15 minus 11 times negative 15? The question is that 105? Well, let's see. What's 4 times negative 15? What's 4 times 15?
15 times 4 is 60.
60. And that's negative, isn't it?
Yes,
Positive
so it's
times
negative 60.
And what's negative 11 times negative 15?
It has to be a positive.
Yeah, negative times negative is positive. And what's 15 times 11?
I have to add these together.
Yeah, so 1 times 15, 1 times 15.
165.
165.
It's positive 165.
So it's positive 165. So what's 165 minus 60?
105.
Which is exactly what we wanted, so our answer checks out. Okay, thanks for the call.
Nicely done. Samantha, you still online with us?
Yeah.
All right, well, you know what? That was such a great problem. We're going to send you over to Johnny Rocket so you can enjoy a meal. Congratulations on that, and thanks for giving us a phone call. We do have phone tutors available until 5:30. The phone number is 636-4357. Did you know how to do that problem?
Yeah.
Yeah? You ready to do some more like that?
Yeah.
Well, maybe we will. But it's always nice to see things like that, because also if you haven't done a problem like that, I'm sure you'll see it at some point in the future of 6th grade, right? All right, well, you know what? Speaking of 6th grade and all of the other grades, we're going to head out to Franklin Elementary right now with Mary Lou.
Thanks, Mike. We're here at Franklin Elementary School, and I'm here with Elena. Hello.
Hi.
How you doing today?
Good.
Now, what grade are you in?
I'm in 4th grade.
4th grade. What is your favorite thing about 4th grade this year?
Well, I'm starting to like the math. I'm understanding it more.
Yeah, but is that your very favorite thing to do? Is there something else?
Yeah, it's my favorite thing.
Yeah. What's your second favorite thing to do?
That would be, reading.
Yeah, reading. That's important too, huh? Well, with reading and math, we both have that behind us, don't we? Because we have a math problem that we have to read. Here we go. There are 25 gold paper clips and 75 silver paper clips in each box. How many silver paper clips are in 8 boxes? Well, there's some important information, right, that we need.
Mm-hmm.
Do we really need the information about the 25 gold paper clips?
No.
No, that's unnecessary information. And sometimes they try to trick you, huh? They try to throw in information that you really don't need. We really don't need about the gold. We don't need any information about that. The question is, how many silver paper clips are in the box, right? In 8 boxes, not just one, but in 8, huh? So we know there's 75 in one box, but we need 8 boxes. So Elena, what do we have to do to solve this?
We need to multiply.
We do. So why don't you go ahead and write up our problem, 75 multiplied by 8 up on the board for us. Wow, your 5s are way nicer than mine. And what are you going to multiply first?
I'm going to multiply these 2.
Okay.
So that equals 40.
Very good. And what are we going to do with the 4?
We put it up here.
Okay.
And now we do 8 times 7. That equals 56.
Very good. And what are we going to do with that 4?
We added 4. So 56, 57, 58, 59, 60. So.
And are we done? No, why? Why are we not done?
Because we still need the 25 paper clips.
But that's not, we don't really need that, do we? Because it just wants to know that about silver paper clips, huh? It doesn't really need the 25 paper clips, does it? No, we just want to know how many silver paper clips are in 8 boxes. So looking at our choices here, we have A, 800, B, 640, C, 600, or D, 200. Before we even worked out our problem, Elena, would you guess that D, 200 was way too small? Yeah, I would have guessed that's way too small, because even estimating 75 in one box, and we need 8 boxes, that's almost, if I even estimated that to 100, that's going to be around 800, huh? And that's way too low, isn't it? But we know that it's what? 600. Okay, so go ahead and circle our correct answer. Where is it?
This one.
It's right there, isn't it?
Yeah.
And there you go. All right, awesome job today. Reading and math, huh? Great job. All right, Mike, back to you in the studio.
All right, nicely done with Elaine out there at Franklin Elementary. We do have phone tutors available until 5:30. Don't forget, you can always email us also at dothemath@kern.org, because our students that have emailed us, and today and tomorrow are the best days to email us if you have a problem and you can't get on the phone, something's going on, you're not able to watch the program. Email us today and tomorrow. That way we can get back to you tonight or tomorrow.
So you don't have to wait a week to see it on next week's show, right?
Yeah, you get homework on Friday and you're like, oh, let me email it in. We won't be able to get back to you until Wednesday. So hopefully if you need to email us, you can do it on a Tuesday or Wednesday. Sean, you feel loose, ready to go?
Yeah.
All right, over to the board, young man.
Yay.
Your math homework looks like you are multiplying fractions. So let's go ahead and, let's see, let's try this one. 2/5. So 2 over 5. times 1 over 9. And as you're doing that, explain to us what you're doing and where you're getting numbers from and the procedure you're going through. All right?
So we would have to do the 5 times the 9, and then the 2 times the 1.
So just both numbers on the bottom and both numbers on the
Yeah.
top? Okay, so what answer do you get over there?
So with that, you would get 2 over 45.
And can you reduce 2 over 45? Because I know they always ask you to simplify fractions, right?
No, we cannot.
And how do you know that?
Because 1 is even, 1 is odd.
Yeah, and nothing goes into both 2 and 45. 'Cause
Yeah.
like you said, 2 is even.
2 would go to 44 or 46, but not
And
45.
that's your answer. Great.
All right, nicely done. So that's the warm-up one for you, all right? So we'll let Chuck erase the board, and we'll get another one ready for you right now. So now it's the whole number 8
Okay.
times 3 over 4. So this one's a little different because they're not both fractions right now. So explain to us what we need to do.
So what we need to do is make this a fraction. And so like that would equal 8 over 1 because, there's 8 ones. So 8.
Because we know that a fraction sign means division, right? So 8 divided by 1 is 8, doesn't
Yeah.
it? Right.
So multiply that by 3/4. 1 times 4 is 4, and 8 times 3 is 24. And then what I would do is simplify.
Yeah, so now there's 2 parts to this, right? When you say simplify, what are you going to do first?
Make the mixed number.
Okay, so let's make it into a mixed number. Now, how do you know it's a mixed number?
Because the numerator is greater than the denominator.
Right. Top-heavy fraction or improper fraction, right?
Yeah.
So what do you get?
Do this, you would get 6.
So 4 goes into 24 6
times.
times with what left over?
0.
So you don't really get a mixed number for an answer, do you?
No, you get a whole number.
You just get a nice whole number. So our answer is just equals 6. And we're done.
Now, before I let you go, I'd like you, Sean, because there are going to be times when you work with larger numbers. I want you to see if you can simplify before you multiply. So take a look at the problem that you just did.
So you had a choice. When you multiplied, you got 24 over 6, or 24 over 4, and you got 6.
Yeah.
So you reduced here. Mr. Cushon's question is, can you reduce here? Have you ever reduced in the problem before you multiplied?
I don't think so.
So here's what you can think. You don't always write this down, but what you can think of is 8 times 3 is just what you do on top, isn't it? And 1 times 4 is what you do on the bottom.
Yeah.
So really, when they say multiplying fractions, you multiply the numerator and you multiply the denominator. But now if I think of this as one big fraction, does anything on the top reduce with anything on the bottom?
Oh yeah, the 8 and a 4.
8 and 4, what goes into both 8 and 4?
4.
4, so divide them both by 4, what do you get? So cross that out and it
This
becomes
would be 2.
and cross that out
This
and it's
would
a,
be a 1.
so now multiply. What do you get on top?
The 1 times 3 is 3.
No, what is this out?
2.
It's a 2, so go ahead and erase that 3.
Kind of looks like a 1 to me.
Yeah.
Even though it's my own handwriting. So 2 times 3 is 6.
And on the bottom?
And then 1 times 1 is 1.
And you said the whole number 8 was 8 over 1, but we also know that the fraction 6 over 1 is equal to?
6.
And there's your answer. So like we were saying, if the numbers are really big, now this wasn't too bad of a problem, but if you had like 24s and 16s and 38s, this could be a really big number when you multiply. So this just makes the problem easier.
Yeah.
Great.
All right, nicely done. And a perfect example of why it's important to write your numerals clearly so that you know exactly what it is. All right, come on back over here, Sean. 636-4357 is the phone number. We do have phone tutors available until 5:30. Right now, we're going to head up the hill to Tehachapi Jacobson Middle School. Julio, how are you today?
Good.
What grade are you in?
6th grade.
All right, as soon as you're ready, let's hear the math problem you're working on.
Which group contains radios that are all equivalent to 4 to 36?
I'm sorry.
All right, so we're looking for ratios.
So
that are equivalent to 4 to 36.
So is it written 4 to 36 like this, Jacob?
It's 4.
And the 2 dots?
Yeah.
There you go.
So 4 to 36, that's another, so there's your ratio, right? And so we want to compare some other ratios to this?
Yeah.
Okay, so what other information are you given in the problem?
Well, it just gives me that are all equivalent.
So what options do they give you? Do they give you some options to look at?
Yeah, they give me 1 to 9, 2 to 10, 3 to 11, 9 to 1, 18 to 2, 27 to 3, 1 to 9, 2 to 27, and 2 to 36, 1 to 9, 2 to 18, and 3 to 27.
All right, here's what we're going to do. You had a lot of stuff right there. So Chuck, erase those. I've got them written down here in a different thing, so it might make a little more sense.
Okay. So let's see if we can get rid of this. No.
You got rid of it, all right. You moved
I
it.
sure did, didn't I? Here, I can do this.
There you go. All right, so we're going to have 4 options, A, B, C, and D. Each one of those options will have 3 parts to it.
Oh, okay.
So A is 1 to 9.
1 to 9.
As well as 2 to 10.
2 to 10.
And 3 to 11.
3 to 11.
Option B is 9 to 1, 18 to 2, and 27 to 3.
27 to 3.
Part C, 1 to 9, 2 to 27, 3 to 36. Part D, 1 to 9, 2 to 18, and finally 3 to 27. Julio, take a look at the board and see if those are all written up there accurately and those are the ones that you're working with.
Okay, hold on.
Okay. And that's a 2.
So you ready to go, Julio?
Yeah.
Okay, so Julio, we want to compare this to one of those lists, right? So we're hoping that all of these should be the same. So let's go ahead and go back to the problem that you're given, right? So 4 to 36. Can you simplify or reduce 4 to 36?
Yeah.
What's that reduced down to? What's that the same as?
Actually, you can simplify it by 9.
By 9, right? So 4 to 36, do you write ratios as fractions also?
Yeah.
So we could write that as 4 to 36, right?
Yeah.
And you said 9, so 4 goes into 4 one time, and 4 goes into 36 9 times, is that right?
Yeah.
So if we were going to put it in the same form, we would write this 1 to 9, correct? So it looks like the ratio that they gave you is 1 to 9. So here, let's go look at our choices. So we know it can't be B, right? Because that's 9 to 1. So this is 1 to 9. Is 2 to 10 the same as 1 to 9? What's 2 to 10 reduced to?
2 to 10 is reduced. 2 to 10 is reduced to 5.
5, right? So it's going to be 1 to 5, isn't it?
Yeah.
Which is not the same, right? 1 to 9 and 1 to 5 are different, so that's not going to work either, is it?
No.
How about C? We have 1 to 9, which is what we wanted. Does 2 to 27 reduce to 1 to 9? Can you simplify 2 to 27? 2 goes into 2 once, but 2 doesn't go into 27, does it?
No.
So that doesn't work, so C doesn't work, so I hope it's D, right?
Yeah.
Let's see, 1 to 9, yep, that's what we needed. How about 2 to 18?
Yeah.
Divide by 2, divide by 2, right? How about 3 to 27?
3 times 9.
So 3 divided by 3 is 1, and 27 divided by 3 is 9. they all give me the same ratio of 1 to 9, don't they? So it looks like your answer to this problem is D. Those all reduce down to the same ratio that you started with. Okay? Thanks for the call.
All right, nicely done. Do remember, Julio, we have phone tutors available until 5:30. We'll be back with more right after this. Today we're at scenic Fraser Park, home of El Cajon School, and today we're here to... Once again, we're at El Cajon School. I've got 8th grade student Giggles with me here. Sarah, how are you today?
Good.
All right, you going to be able to do this problem?
I hope so.
All right, here we go. Let's go ahead and turn around. All right, go ahead and put the number 30 up there. Do you know what a factor is? A factor of a number. What's a factor?
The numbers that will multiply to make 30.
Okay, numbers that will go into 30 evenly, right? How many positive factors does 30 have? So how would you figure that out? We want to
4.
know how many factors 30 has.
4.
So,
So there's 1 and 30,
okay,
and then 2 and 15, and then 5 and 6.
anything else go into 30?
No.
All right, so you went from 1 to 2, because you know 1 will go into anything, multiplied by itself. Then you know 2. How did you know 2 went into 30?
It's an even number?
It's an even number, and you know 2 times 15 will be that. How did you jump to 5 then?
Oh, I missed one.
You missed one. What'd you miss?
3 and 10.
Oh, okay.
And
So now how many factors does it have?
8.
All right, so the first time you had 6, now you've got 8. Are you sure you're gonna stick with 8?
Yeah.
Positive. You don't get to change it again. You set?
Yeah.
All right. So we know the 1 times 30, 2 times 15, the one that you missed, but you realized was 3. 3 times 10, but then you went to 5. What's the matter with 4?
It doesn't go into it evenly?
It doesn't go into it evenly, right? So you know to skip that, and by knowing your multiplication facts, you know that. So then you go to 5, and then you went to 6, right? Because 5 times 6. How do you know to stop then?
Because 7 doesn't go into it. Maybe it does 8
Okay.
or 9, and then you already have 10.
Okay, but why don't we do all the other ones? So I'm trying to see if you know that. I mean, you realized it, but I want to see if you understand how you knew to stop then.
Well, 'cause nothing else goes into it evenly.
Right. See, the 5 and the 6 are right next to each other, right?
Yeah.
So once you go 5 and then 6, right, and these are each other, you know you're done. That's how you can tell, because sometimes you'll have a large number that you have to do this with, and when you get the numbers right next to each other like that, you know you're all set, as long as you have all these other ones in there, all right? So you first of all had 6, but then you realized that it were really 8. Sarah, nicely done. Easy enough problem, wasn't it?
Yep.
Okay. We're at El Cajon School. 8th grade student Story is with me, and we're about to work on some triangles.
Okay.
You ready?
Yes.
Finally, we can get to this. All right. So there are 3 main types of triangles. We have an equilateral triangle. What can you tell me about that?
It has all equal size, all equal sides.
Okay. Why don't you just go ahead, and it doesn't have to be perfect, but draw me an equilateral triangle.
Okay.
Good. So by putting those marks in there, you're identifying that all of the angles are the same. Okay? But we could even go pretty far on this. What's the measure of each of those?
It depends on how big the triangle is.
Well, how many
Right.
how many degrees are going to be in a triangle?
360, right?
That's in a quadrilateral. So in a triangle, we're going to have 180.
Okay.
All right. So,
All right.
but we're not even going to deal with that. So we have an
Okay.
equilateral triangle. All right. What is another type of triangle?
Isosceles
Isosceles. And tell me about an isosceles.
has 2 equal sides, but
Right.
one of them isn't.
Right. So let's say you have 2 longer sides and one's very short at the bottom or whatever. So go ahead and draw me out an isosceles. There you go, nicely done. So obviously not all the same.
Yeah.
And what is the other one? There's a third type of triangle, a scalene.
Scalene.
There you go, scalene. And what's the
Scalene.
deal with a scalene?
It has no equal.
So go ahead and try your hand at that one.
No.
There you go. There,
No.
Just showing that one up. There you go.
I'll do that.
All right,
Because that looks like it'll work.
that'll work. So we're going to work with the isosceles one.
Okay.
All right. So two of the sides measure 15 centimeters and the other is 10 centimeters.
15. Do you want me to write that bigger?
Well-
Is that okay?
No, how do you know that the two are 15 and not 2 or 10?
Oh.
Okay, so you're doing the angle.
Wait, didn't you say 2?
Well, here are the two measurements.
Okay.
One side, all right, one side is going to be 15 centimeters. That's the length of one side.
Okay.
The other side is 10 centimeters. All right?
Okay.
So we have two of the three sides. The question is, what is the maximum length perimeter of the triangle? What can the maximum be? So you can make one 15 and one 10. So how would you like to label those? So which one would you like to, if you're looking for the maximum?
The maximum, you would have the 2 bigger. 15.
Okay, so where would you put the 15?
The 15 on the side.
And the 10 would go. So then what would the maximum be?
The maximum would be.
The perimeter would be?
40.
Right, it would be 40.
Yeah,
Right.
40
So
centimeters.
The maximum would be 40 centimeters. All right? And that's the answer. That's what I was looking for.
Okay.
If you wanted to do it differently, if I said what was the lowest it could be, how would you label it then?
I'll just do that.
And then what would it be?
Be 35 centimeters.
There you go. All right. Nicely done. Not that bad, was it?
Nope.
All right. No need to get nervous.
Louise Rodriguez, please come to the office.
And once again, a big thanks to all the students at El Cajon. We had a great time up there. All of the students were great to work with, and thanks also to the staff. Made it most welcoming for us up there. We do have phone tutors available until 5:30. Right now, we'll go back out live to Franklin Elementary and Mary Lou.
Thanks, Mike. We are back here live at Franklin Elementary School, and I'm with Diana.
Hi.
Hello. What grade are you in?
5th grade.
And what is your favorite thing?
My favorite thing is math, and I love to draw.
Yay! That's important, isn't it?
Yes.
Okay, well, we got some math behind us, don't we?
Yes.
All right,
we
let's
do.
take care of it. We got a lot of numbers, and it's dividing, isn't it?
Yes, it is.
Now, before you learn to divide, there's an important step, and what is that?
That you have to know which numbers go into each. Like, for example, if you're going to do 15 and 3, you have to know which goes into 15, so it would be 5, because 3 times 5 is 15.
Very good. So division's just backwards from multiplication.
Yes.
Very good. But another important thing when we get to really big numbers, because the example you gave us, small numbers, right?
Yes.
But now we get into big numbers, triple,
Yeah.
double digit, and triple, right? So
Yeah.
to help us, we need to use estimation, right?
Yes.
Okay, so if I have a problem like this, I have 304 divided by 18. To help me out, I can first estimate it. So if I'm estimating 300 to the nearest hundreds, Diana, what would that be?
That would be 800.
And if I want to estimate 18 to the nearest tens to help me divide this, what would I estimate that to? Now that would round up, right?
Yes.
And that one rounded?
Down.
Okay, when do we know when to round up and when to round down?
When you know when to round up and when to round down is if there's a bigger number, then you have to change that little number into the second number.
And if it's anything 5 or up, right?
Yes.
Above 5.
Yes.
And if it's anything below 5, then we
keep it together.
Very good. Okay, so now we can look at this and we could quickly divide. We could think of this as actually, if we think of it, 2 goes into 30 about. What do you think? So we could use estimation kind of help us out, right?
Yes.
So 20 goes into 30 how many times?
One time.
One time, right?
Yes.
And then we would have about 10 left over, right?
Yes, we will.
So then we know that
We need to cross out the zeros, and then how many zeros we cross out, and if we have one left over, we put the zero on the side.
there you go. So it's 10.
10.
Awesome. Better than me. Let's do this one up here.
Okay.
Talk us through it.
Okay, so if you have 512, you'd have to run and turn it into 500, and then put our division sign. And then, since it's a low number, we do not change it at all. So we bring this down, and it would be 50.
Oh, you're fine.
So it would be 50, and then we would have to cross out the zeros, and then we would have 10, because 5 times 1 equals 5, because it is multiplying the same number.
Very good. Our last one. Now this one is a little different. Here we had our division sign, but
Yes.
here we have the house, right? The division symbol.
Yes.
Okay. Inside is our dividend, which is our first number, correct?
Yes.
And outside is our divisor, which is our second number. How can I rewrite this with estimation?
Well, usually I would round it
What could we round this to?
to the nearest 10.
Okay. To the nearest 10, or can we round it using hundreds?
Yes.
What can you round that to?
We
Would that-
could round it into
Would it round to 400 or 500?
500.
Okay, there you go. Because of the 5, right?
Yes.
We got to round up.
Yes, you do.
Okay. And our 31's going to round to?
30.
Okay. And work your magic there.
Okay, so, and then I think 3 goes into 5 one time.
Well, let's think about it this way. 30 goes into 50, what? Does it go one time? Yeah, let's put the 1 there, okay?
Okay.
Because we know 1 times 30 is just?
1.
Is 30, right?
Yes.
What's left over?
It is.
Bring down that. So then we can keep on from there, huh?
Yes.
All right, good job. But estimating is important. It gets us to where we need, right?
Yes.
Good job today, Diana. All right, Mike, back to you at the studio.
All right, Diana doing some division and some divisibility, which leads us into our next phone call right now. We'll go out. We've got a 6th grade student from Reagan Elementary. Aditya, how are you today?
I'm good.
Why don't you go ahead and read the math problem so that everybody is aware of what you need to do, and then we'll have Chuck help you out with it.
Okay. So my question is, find a number less than 500 that's a multiple of 11, but when it's divided by 4, 6, 8, and 10, it leaves a remainder of 3.
With remainder of 10. Okay, so find a number, you said less than 500?
Yes.
Let me see if I can get this back up here. I guess not. So let me get this. It's not going to move. So find a number less than 500. It's a multiple of 11?
Yes.
And when it's divided by 4, 6, 8, or 10, it has a remainder of 3, right?
Yes.
All right, so I guess one way we could do this problem is we could list all of the multiples of 11, right?
Yeah.
But there's a lot of them. There's a lot of multiples of 11 less than 500. So let's go to these divisions, right? If you divide by 4, they want a remainder of 3, right?
Yes.
And you divide by 6, and we divide by 8, and divide by 10. So do you know where you would start in this problem?
Wait, what?
Where would you start in this problem?
I would start by trying to find I don't know.
Well, let's start with multiples of 11, right?
Yeah.
But here's the clue. And this is the easiest number to divide by, isn't it? dividing by 10?
Yeah.
So if I divide a number by 10 and I get a remainder of 3, I know that number has to end with 3, don't I?
Oh, okay.
Doesn't it? So I know that the number we're looking for, the number that I'm looking for, has to end in a 3, doesn't it?
Yes.
So let's look at multiples of 11 that end in 3. Right?
Okay.
So I'm going to start with 11, but I don't want 22, do I?
No.
Because that doesn't end in a 3. But how about 33?
Yes.
Isn't that 3 times 11?
Yeah.
Now 4 times 11 is not going to work, and 5, nothing else is going to work. What's the next multiple of 11 that ends in a 3? Isn't it going to be 11 times 13?
Yeah. 143.
143?
43. Yeah.
Right? And the next multiple of 11 that ends in 3 is going to be times 23.
Isn't it going to be 253?
53? I'm sorry, 63 did you say?
253.
253?
Yeah.
Okay. And then times 33, because that's the next number that ends in 3. What's 11 times 33?
363.
363. That's still under 500, so let's go times 43. What's that?
473.
473. All right, so I know that these are all multiples of 11, and I know that when I divide by 10, I get a remainder of 3. How about if I divide by 4?
By 4.
Do I get a remainder of 3? So let's see, if I divide this by 4, do I get a remainder of 3? I don't, do I?
No.
So this doesn't work. If I divide this by 4, do I get a remainder of 3?
No.
No?
No.
No, so that doesn't work. If I divide this by 4, do I get a remainder of 3? Again, it's pretty easy, right? Either use a calculator or just take 253 and divide by 4. Did you get something? Doesn't work, does it?
No.
Nope, that's going to be, whoops, that's going to be a 3. That's going to be a remainder of 1, so that doesn't work. And notice I haven't even worked with the 6 and the 8, have I? How about 363?
400.
Does 4 go into 363? Very nicely. It goes in there 90 times, doesn't it?
No. It's 90 remainder 3.
Yeah, and there's my remainder 3. So this one works for 4. Does it work with 6?
Yes.
Yes, because 6 goes into 36. Does it work with 8?
Yes.
It turns out that it's 45 remainder 3, doesn't it? And we already know it works with 10. And so I'm going to guess that this is my answer because 473 I don't think is going to work for any of those. So it looks like 363 is going to be our answer.
Okay.
Okay? And again, what we did was we didn't look at all of the multiples of 11, just the ones that ended in 3.
Okay.
Right? Great question. Thanks for calling.
Yeah, nicely done. Great problem right there. All right, erase the board. Sean, back to work with you, young man. So we've done multiplied fractions. We've multiplied a fraction by a whole number. Now let's do some mixed numbers, multiplying those. All right, so we've got 1 2/5. We're going to multiply that by 4 2/7. So explain to us how you would approach that problem.
How I would approach this, I would do the 7 times 4, which is 28, and then add it by the 2, which is 30.
So let's write that down here. So what are you going to write 4 2/7 as?
So I would as 7 on the bottom, because same denominator. And then since what I did in 30 would be the numerator.
So one of the other problems we did, you had a mixed number. I mean, you had an improper fraction and you changed to a mixed number for your answer. And now in this one, you changed from a mixed number to an improper fraction.
Yes.
Because we know we want to multiply two fractions together, right? So how about the 1 2/5?
1 2/5, again, the denominator times the whole number, 5, then add what you get there to the numerator to be 7, right?
Yep.
So 7 over 5.
Mm-hmm. All right, so now you get two fractions to multiply by, right?
Yeah.
Now, here's your choice that we had before, right? You can multiply 7 times 30, and you can multiply 5 times 7, and you get two pretty big numbers, right? 210 and 35. But can you do any reducing before you multiply?
Yes.
What's just jumping right out at you to reduce?
Sevens.
Yeah, you
Sevens.
can divide both of those by 7, can't you?
So this would be 1. This would be 1.
Now, can you do any more reducing?
Yes.
What?
You can do the 5 and the 30.
What goes into both 5 and 30?
5.
5, so divide, what do you get?
This would be 1. And this would be 6.
Wow, isn't that nice? Because what do you get when you multiply the top?
You would get 6.
And what do you get when you multiply the bottom?
1.
So write that down, 6 over 1, because there's our fraction answer, right? 6 over 1. But we wouldn't leave it that way. What's your answer?
It would be 6.
6, and so your answer should be the whole number 6.
Yeah.
So you multiply two mixed numbers together, and you got a nice whole number answer of 6. And there's the problem.
All right, nicely done. 6, the number of the day. Seems like he had that in his last answer right there. All right, we do have phone tutors available until 5:30 on most Tuesdays and Wednesdays. Right now, we're going to go back to the phones. A student from Rosedale Middle School. Morgan, how are you today?
I'm good. How are you?
I'm wonderful. Are you in 6th, 7th, 8th grade? What grade?
I'm in 7th grade.
All right, as soon as you're ready, let's hear the math problem that you're working on.
Alrighty. The problem is 2 is greater than 8 minus 4/3 h.
All right, so this is an inequality. You want to solve for h, don't you?
Yes.
So now we've got to get rid of everything on this side except the h. Now, depending on your teacher or your book, do you want to end up with h on the left side or the right side? Does it matter?
Let's do the left side.
Okay, it's starting over here, but we'd like it over on this side, right? So we like h is greater than or h is less than something, right?
Right.
All right, so you want to do that now? How do you get that h over on the other side?
Okay.
Or do you want to work with the numbers first?
Hang on. Could you say that again?
So do you want to work with the numbers first or the h first?
You want to work with the numbers first.
Okay, so let's get rid of that 8. Let's leave that alone for right now and let's get rid of that 8. How do you do that?
You subtract 8 from both sides.
Yeah, because we know that's a positive 8, so I'm going to subtract. And just like in an equation, in an inequality, you got to do the same thing to both sides, don't you?
Yeah.
So I'll do the easy part. 8 minus 8 is 0. Now I'm going to keep it in the same direction, aren't I?
Yes.
Because subtraction doesn't change the direction, does it? So this side is negative 4/3 h. What do we get on this side? 2 minus 8.
Negative 4/3 h on the right side.
And what do we have on the left side? 2 minus 8 is?
Negative 6.
Negative 6. All right. So we still got the h here, so let's just leave it here. Let's get rid of that negative 4/3. That's being multiplied, isn't it? How do you get rid of multiplication?
You divide.
You divide. So we're going to divide by the number in front of h, which is negative 4/3. Now I could divide by negative 4/3, but what's dividing by a fraction the same as?
Multiplying?
Multiplying by the reciprocal. So let's multiply by the reciprocal of 4/3. What's the reciprocal of negative 4/3?
Negative 3/4.
Negative 3/4. Okay? So we're going to multiply by negative 3/4 here. Now here's where we got to be careful. We just multiplied both sides by a negative number, right?
Yeah.
So that means I'm going to change the direction. That's important that we do it right now, right?
Yes.
All right, because I know that negative 4/3 times negative 3/4, everything cancels out, doesn't it? Even the negatives, and so I get 1h here. What's negative 3/4 times negative 6?
That would be 9/2, which equals...
Okay, how did you get 9/2?
Okay.
How did you get 9/2?
I got 9 over 2. I cross-canceled the 6 and the 4.
So you reduce the 6 and 4, 2 goes into both of them, right?
Yeah.
Negative times negative is positive, that's 9 over 2, right?
Yeah.
So 9/2 is less than h. Now if you wanted to put the h on the other side, I could say h is greater than 9/2, couldn't I?
Yes.
Can you leave your answer as 9/2?
No, you have to simplify.
So h is greater than, what's 9/2?
9/2 is, that would be 4.5.
4.5.
There you go. Nicely
And
done
that
right
should be
there.
your answer.
And
Great,
for
thanks
such a
for
great
calling.
problem, we're going to send you to the movies, courtesy of our friends at Maya Cinema. So congratulations on that. 636-4357 is the phone number. We do have phone tutors available until 5:30. We'll go out one more time to Franklin Elementary and Mary Lou.
Thanks, Mike. We are back here at Franklin Elementary School, and I'm with Samuel. Hello.
Hello.
And what grade are you in?
6.
Okay, Samuel, we got a problem behind us, right?
Mm-hmm.
Okay, so a bookstore was selling 6 books for $31.38. Online, you could buy 3 books for $16.02. Which place has a lower unit price? So we got to compare, right? Okay, we're going to make a race out of this. You ready? Which one would you like to figure out?
Online.
The online, the 3 books? Okay, so let's go ahead, then I'm going to figure out the other. So let's go ahead and write our problem out. So I have the $31.38, 6 books, and you have the 3 books for $16.02. Ready, set, go. Tell us what you're doing.
I'm going to divide 3 by 16. So if I do 3 times 5, 3 times 5 is 15. So 15 is equal to 16. And I'll get 1 out of 16 minus 15. And then I add the 0 down. And since 10 is not a compatible number with 3, I have to do a number lower than it. So I'm going to do 3 because 3 times 3 is 9. And 10 minus 9 is 1. And putting down the 2 as well. And times 4 is 3 times 4 is 12. And that is my answer.
Okay, and over here, I'm last. I'm at the end one, and 6 goes into 18. I know 3 times. So Samuel, looking at these, you have $5.34 per book, and I have $5.23 per book. Which would you say is the better buy?
I would say the bookstore.
The bookstore, yeah, $5, because it's a lower price, isn't it? Yeah, and again, we had a lot of dividing to do, huh? Great job today. And Mike, back to you at the studio. It's been a blast here at Franklin today.
All right, you know what? We always enjoy the students over at Franklin Elementary, and a great job by all of those students out there. Do remember we have phone tutors available until 5:30 over in San Luis Obispo County. That phone number is toll free at 1-866-636-6284. Don't forget, all the girls, they've got things going on Twitter, YouTube, Facebook, all the different things, and you can always go check them out. Sean, as we do every day, somebody's going to see the Condor, so why don't you put your hand in there and we'll find out who's going.
And it is Elena.
Elena, the 4th grade student from Franklin Elementary. Congratulations, Elena, going to see the Condors.
All right.
All right, until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, California Resources Corporation, Southern California Edison, Kern Schools Federal Credit Union, Panama Buena Vista Union School District, and the San Luis Obispo County Office of Education, with additional production assistance provided by the supporters of education in Kern County and throughout the state of California.